Today, I will present you the principles of the infrastructure as code. So, as Luci mentioned, we are working for one of the leading companies in software security, and they want us to create, they had a requirement to create an automation platform for deploy their infrastructure and also automation and orchestration. So, first of all, I will go with some introduction about the infrastructure as a code from the DevOps movement. As Jonathan mentioned in his presentation, in the past there was very hard to deploy and maintain a lot of servers. It was very time consuming and the maintenance was very expensive. Lately, with moving into the cloud, the deployment was easier to do it, but still the configuration it still needs to be done, and there was maybe some inconsistencies in the configuration. With infrastructure as code, having a definition, still works? Yeah. Having a definition of a deployment and a configuration and a server, you can assure this consistency of the deployments and having all the servers configured in the same way. I was telling you about this definition. Consider this as a configuration file where you define how you deploy the server, how you configure it, what application you install, what are my network configuration, and all the stuff. You write this, and you can replicate it as many times as you want. This you may consider that, okay, it's really good to deploy production environments and maintain them very easily. It's not only that, it also enables us to follow practices from software development, like CI, CD, or TDD. This configuration file, I said, it provides consistency. It can be replicated anywhere as many times as you want, and any change that it suffers, it can be tracked using source control systems like Git. Let's say you said you changed some configuration in your Nginx. You just change that configuration file, you execute it across all your servers, and you know that everything is consistent. And let's say that change breaks something, you can see what changed and revert. Okay, I want to give you some context. So, as I was saying, we're working for a leading company in software security. So, me and my team, we are building this automation framework for them. So, my team as DevOps practitioners, so we have the sysadmins and the development team working all together for the common goal to facilitate the orchestration and automation for the end users. Basically, an automation framework, a traditional automation framework, so if a user wants to start automate, he requires to set up his environment, install OS, install different tools, let's say Jenkins or Selenium server, start coding, implement libraries, and he needs to take care about all the stuff. What we are providing as a team for the users inside their company, their developers and testers, is an automation as a service. So we build the whole stack except the scripts that the end users need to focus on. So they only need to take care about of the test logic. So why we took this approach? We had previously implemented the old-fashioned automation framework, and I think it happens to all of us. What the image says, it worked fine on my laptop or in my environment. It doesn't work on my colleague's environment or in production. There is another case. There are developers that, let's say they come on board. They need to set up a lot of stuff to start developing. It can take up to several days to set up a VM, install all the tools, set all the configuration files, and so on. The other case is, let's say, QA people. They need to install they require some devices to install. They also can spend a lot of time setting up devices. So with infrastructure as code and with our approach of automation and its service, we try to remove this. So the advantages that we saw by using this principle, first is one for me and my team that we are building this product, and on the other hand for the end users that are using this product. In our case, by providing this solution, we can spend time on valuable things and innovate and create better features and new features for the users. And on the other side, they can self-manage their resources. They can quickly recover for the failures. And that's it. I will go next how we are building this product. So this product it's built internal for the company that we're working on. It has more than 500 users, unique users currently, and it's a production environment, but it is used internal inside the company. So for this, someone mentioned Docker. So we are using Docker. For the ones which are not quite familiar with it, Docker leverages Docker containers to build, ship, and execute an application anywhere. Anywhere, it means it can be bare metal, it can be cloud, or it can be a virtual environment. It runs on any major Linux distribution and Windows, and it runs at the OS level. A Docker container, basically, it's an instance of a Docker image, where a Docker image, it's basically a definition done based on the file system share. I will show you later exactly what this means. Interesting, let's say, particularity of the Docker container is that every Docker container runs in an isolated environment. So let's say you have an application, a web server application in one container and another application in a database in another container. If the database container crashes, it doesn't affect the web application. And everything that happens in one container just affects that container. You can remove /, for example. Okay, to give you a better view of what Docker is, I will make a quick comparison with the VM, with the virtual machines. So as you know, the VMs are an abstraction of the physical layer. On the other side, Docker is the abstraction of the application layer. Also, Docker containers they are using less resources, and they also start instantly, as almost any other application that you run on a host. So I will keep telling you about the product that we are building. So in the following, I will go over some of the features that we created on top of Docker to control it, and the user, they can use it to manage their resources. So first of all, we will need a Docker image from where to start on to create our container. So we have an image manager. Just to rewind a bit, everything is controlled from a UI application. And this UI application, basically, we control any of the Docker instances that we have. OK, so we have the image manager, where you can write your definition of the Docker image. This is a basic example of it. It's based on a Ubuntu image. You copy your local application inside, compile, and set the default command to start your server when the container starts. This image is built and pushed to a Docker registry. A Docker registry, imagine as a Git central repository. Going further, we want to run this image, our web application that we just built. We want to run somewhere. So for this, we would require a host, a machine where to run it. Our infrastructure, it relies on the vCenter. We call it as an execution environment. There we put everything that we need for execution. And we have a feature called personal execution server. So by a click of a button, you can deploy inside the vCenter a VM with Docker installed and all the dependencies for the framework to work. OK, so now we have the image, we have the VM, we are ready to execute stuff. In order to control the Docker we created, we have three services. First is the container as a service. Imagine this as a manager where you can select where to run and what image to run there. You control basically the execution of the container. So using this container as a service, you can specify run my image that I just built, and bump, the web server will be up in a matter of seconds. The other service that we provide is Selenium microservice. With Selenium, a lot of people had a struggle to set up the server instance, and after setup, after a few days, maybe they get some errors and they need to redeploy. With this Selenium microservice, by a click of a button, we set up a Selenium instance. You get all the details, and you can start using it. So this will spin up a Selenium container. Then, least but not least, we have a testbed as a service. So the company produces software in a software security equipment and software. And they require to test their products using our automation framework. In order to test their software, and they also provide virtual instances of their, let's say, hardware. And basically, they have some typical topologies, group of hosts and VLAN configuration or network configuration, which they deploy, let's say, almost every time they want to test the product that they are providing to the customer. And in order to facilitate easier deployment of that topology, we created this testbed as a service, which by a click of a button, we spin up a container which has all the necessary scripts and libraries inside, so that it creates this topology file. It means it creates all the VMs, it creates all the necessary VLAN configuration, and it returns you all the data so you can start using it for your automated tests. All these three services are also available to use using Python. So imagine controlling all of these containers, whatever container you want, web application, and so on, or even the Selenium or testbed as a service, you can control it everything from Python code. I was saying about Selenium, and you saw there is a separate service. You may wonder why we didn't put it in the container as a service. We put it separately because our Selenium solution with using Docker, it incorporates more services. It has, let's say, all the combinations of Chrome, Firefox, and Selenium version based on a compatibility map. So we're building images for each of these combinations so that we can spin up the containers really fast. We don't need to wait until it's installed a separate version of Selenium or the browser. We have a VNC live session where you can connect with a VNC client or a web VNC, so you can monitor exactly what the Selenium instance does during your testing. Screenshot, and also a DVR which records the screen, and you can download the file at the end, so you can upload it as a log file. So you know exactly what happened in the browser, not only some prints that you may put or not. Here, we will keep talking about infra as a code. Here is a code example for what I've mentioned before about deploying in the first 22 lines. There's a connection to the vCenter. And after that, there's 4 device setup. I mean deployment into the vCenter. And after that, there's the VLAN mapping of their interfaces. OK, so now we have the hosts. We want to go further and, let's say, do a basic test. Into how many lines? I think 6 lines of code. We want to do a basic Selenium test, so we can spin up in 1 line of code the Selenium container. In, I think, about 5 seconds it starts. You get all the details about it, start the recording on that Selenium instance, and at the end navigate on the login page. So this, everything, it can be controlled. You don't need to set up any VM. You don't need to know where's the hardware, where's the vCenter, and you can control everything from the code. This code example, we want to go even further with it. We don't want to, since we have typical topologies, let's say this, where we deployed 4 hosts. This is a typical, I think it's used in about 70% by the tests. We want to go even further so that the user will just need to write like 5 lines of code, or even less without the prints. So you just specify where and what type of the topology. It's 3 hosts, 4 hosts, 5 hosts, whatever. Call the deploy API, and after that you get all the required data so you can do your testing against these devices. I want to tell you about some of the challenges that we had. So we have the container as a service. We have a lot of containers running, 500 plus users, everyone running some test automation, some Selenium testing. Selenium is very resource consuming. and we had a scale problem using the Docker. So we choose to use Docker Swarm, which is the cluster configuration for Docker. And with this, based on the resource monitoring, we can scale very fast and just keep adding other VM instances, and we can just join the Docker Swarm. We had a lot of users asking, OK, we deploy these resources. Why just not keep them running? Should I keep them running? Should I destroy it? Our suggestion, based on what we are building, is that consider these Docker containers as ephemeral objects. So as I just presented in the slide with the code example, consider, let's say, you have a test. You need some devices. You need a Selenium server. I don't know, maybe some Jenkins. Why not? You do this in the setup phase of your script. You do your stuff, and at the end, you tear down everything. Of course, if you want to have like production running applications that you may want to keep them running, of course, then sure, you can use long-running containers. What we saw as opportunities, on the other hand, we had recent requests from one of the teams inside the company to simulate 1,000 plus VPN connections from different networks. With Docker, this was very easy to implement. We just created an image, install the VPN client inside, maybe just put some basic traffic generator or something like that inside to just generate something, or you can just test if the connection is supported. And by a bash script or one-liner, you can spin up like 1,000 containers, all of that connecting to a single server so that it's very easy to do a load and performance testing with it. Of course, there are infinite possibilities, and this is what Docker can offer from this point of view. That was about it from my side, guys.